Where did numbers come from? It's a question that takes us back to the very dawn of human consciousness, to a time when survival depended on understanding the world around us. They weren't always here. They began with the need to count, a fundamental requirement for managing resources and tracking possessions. Imagine early humans tracking sheep, their livelihood dependent on the size and health of their flock, using fingers or pebbles to keep count. A tangible method to represent each animal under their care. For every sheep, a pebble went in a pouch, a direct correspondence between object and representation. If pebbles were left after the flock returned, some sheep were missing. A simple yet effective system of accountability. This was crucial for survival in a world filled with uncertainty. This simple one-to-one matching was the first step in mathematics, the foundation upon which all complex calculations would eventually be built. Early people also tracked seasons, tribe members, and days, understanding the cyclical nature of time and the importance of community, with marks and notches, a permanent record of their observations and calculations, like the ancient Ishango bone, a testament to early human ingenuity. These tally marks show our instinct to organize the world with numbers and patterns, a fundamental drive to make sense of the chaos around us. Soon, people grouped counts, a more efficient way to manage larger quantities, fives and tens, a natural progression based on our own anatomy, thanks to our fingers creating base systems, a universal language of quantity that transcended spoken words. Base 10 let people invent symbols, abstract representations of numerical values for 1, 10, 100, and so on, a system that allowed for the expression of increasingly larger numbers, making bigger numbers possible, opening up new possibilities for trade, construction, and societal organization. This leap allowed for trade, facilitating the exchange of goods and services, building, enabling the construction of monumental structures, and the first towns. The seeds of civilization were sown, nurtured by the power of numbers. Every number you use has a story that began with a shepherd and a handful of stones, a humble origin for a concept that would reshape the world. Numbers weren't just for arithmetic, they became a tool for understanding the very fabric of reality. They changed how humans thought, abstract reasoning, logical deduction, and the ability to model the world around them. This was the spark for thousands of years of discovery, a catalyst for innovation and progress that continues to this day. The journey of mathematics is the journey of human curiosity, a relentless pursuit of knowledge and understanding. It all started with a simple question, a fundamental inquiry that set humanity on a path of intellectual exploration. How many? A question that echoes through the ages, driving us to quantify, measure, and understand the universe. And from there, the world would never be the same. The power of numbers had been unleashed, forever changing the course of human history. Fast forward to ancient Egypt and Babylon, huge empires with big problems to solve. Egyptians used math to build pyramids and redraw fields after the Nile's floods, using ropes and right-angled triangles. Their number system used hieroglyphs, strokes, heel bones, coils, and lotus flowers to count and manage resources. Meanwhile, Babylonians counted in 60s, a system we still use for time and angles. Their base 60 made fractions and astronomy easier, and they wrote on clay tablets in cuneiform. Babylonians solved equations and understood square roots, astonishing for their time. Both empires used math to organize, build, and govern. Their practical needs drove mathematical innovation. These civilizations proved math was the ultimate tool for building society. The legacy of their systems still shapes our world today. Now, let's embark on a journey, sailing through time and across the azure waters of the Mediterranean to ancient Greece. Imagine the sun-drenched shores and the vibrant culture that once thrived here. This is where mathematics transcended its practical applications and became something far grander, a profound quest for truth and understanding. It was no longer just about counting and measuring, it was about uncovering the fundamental principles that govern the cosmos. The Greeks were not content with simply knowing that something worked. They yearned to understand why. They sought to uncover the underlying reasons and establish irrefutable explanations for the phenomena they observed. This led to the introduction of logic and rigorous proof into the realm of mathematics. They developed systems of reasoning that allowed them to build upon established truths and arrive at new conclusions with certainty. Pythagoras, a name synonymous with mathematical brilliance, delved into the beauty and profound mystery of numbers. He saw in them not just quantities but also patterns, relationships, and a hidden order that permeated the universe. He meticulously proved fundamental relationships such as the iconic A2 plus B2 equals sign C2, forever linking the sides of a right triangle in a simple yet powerful equation. In their relentless pursuit of mathematical truth, they stumbled upon the existence of irrational numbers, lengths that defied their understanding, numbers that could not be expressed as simple fractions. This discovery sent shockwaves through their established beliefs, challenging the very foundations of their mathematical worldview. Euclid, a towering figure in the history of mathematics, undertook the monumental task of organizing all known mathematical knowledge into a comprehensive treatise known as the Elements. He meticulously constructed his system, starting with a set of simple self-evident axioms and building upon them, step by logical step, to derive a vast array of geometric theorems and propositions. Euclid's rigorous method, emphasizing logical deduction and proof, remains the fundamental blueprint for mathematical reasoning and exposition to this very day. Archimedes, a true polymath, made groundbreaking contributions to a wide range of fields including mathematics. He developed ingenious methods for calculating areas and volumes of complex shapes, and he provided us with a remarkably accurate approximation for the value of pi, a fundamental constant that relates a circle's circumference to its diameter. His approach involved ingeniously using polygons to approximate or trap a circle's circumference between increasingly precise limits. This innovative technique pushed the boundaries of geometry forward, paving the way for future mathematical discoveries. The collective efforts of these brilliant Greek mathematicians transformed mathematics from a mere collection of practical rules into a sophisticated, logical, and abstract system of thought. Their enduring legacy is the concept of mathematics as a beautiful and elegant structure of interconnected ideas, rather than simply a collection of isolated rules and formulas. This profound shift in perspective profoundly inspired generations of thinkers and continues to shape our understanding of mathematics today. The Greeks demonstrated with unparalleled clarity that mathematics possesses the power to unlock the universe's deepest mysteries, from the movements of celestial bodies to the fundamental laws of nature. Their unwavering passion for rigorous proof and logical reasoning irrevocably changed the course of intellectual history and continues to shape the world we inhabit. As Greece faded, its intellectual dominance began to wane. The torch of mathematical innovation, once brightly burning in the Mediterranean, started to flicker. The great thinkers and mathematicians who had laid the foundations of geometry and logic were slowly giving way to new centers of learning and discovery. Math flourished in India and China. These ancient civilizations, geographically distant from Greece, were independently developing sophisticated mathematical systems and making groundbreaking contributions to the field. Indian mathematicians gave us zero, a concept so profound, so revolutionary, that it would forever change the course of mathematics. Zero was not just a placeholder, a symbol to indicate an empty space, but a number you could use in calculations. It could be added, subtracted, multiplied, and divided, opening up entirely new possibilities in arithmetic and algebra. They developed the Hindu-Arabic numeral system, a system that is now used almost universally around the world. 10 digits, place value, a brilliant and elegant way to represent any number, no matter how large or small, and efficient arithmetic. This system made complex calculations far easier than they had ever been before. Brahmagupta set rules for zero and negative numbers, formalizing their behavior in mathematical operations. A huge leap forward. This was a pivotal moment in the history of mathematics, expanding the number system and paving the way for future discoveries. These ideas made advanced math like algebra possible. The ability to manipulate equations and solve for unknowns became a powerful tool for understanding the world. In China, a parallel mathematical revolution was underway. Counting rods and boards, ingenious tools for calculation, let mathematicians solve complex problems. They tackled everything from engineering challenges to astronomical calculations. They independently discovered the Pythagorean theorem, a fundamental principle of geometry that relates the sides of a right triangle, and created detailed calendars essential for agriculture and governance. Chinese scholars excelled at solving systems of equations, developing methods that were remarkably advanced for their time. Recorded in the 9 chapters on the mathematical art, a comprehensive collection of mathematical problems and solutions. Both cultures pushed math beyond simple counting, transforming it into a powerful tool for understanding the universe. Their innovations shaped the global language of numbers, influencing mathematical development for centuries to come. The invention of zero and place value was a gift to the world, a testament to the power of human ingenuity. Math was now a tool for exploring new worlds of thought, unlocking the secrets of the cosmos and driving human progress. In the Islamic Golden Age, cities like Baghdad became centers of learning. Scholars preserved and expanded on Greek, Indian, and Persian knowledge. Muhammad al-Khwarizmi wrote the book that gave us the word algebra, creating systematic ways to solve equations. His step-by-step methods made math practical for inheritance, trade, and land. Al-Khwarizmi also introduced the Indian number system to the West, and his name became the root of algorithm. The House of Wisdom bridged ancient and new ideas, fueling Europe's next leap forward. Algebra and algorithms from this era still power our world. As ancient knowledge returned to Europe, the Renaissance sparked a new age of curiosity. Artists like Leonardo da Vinci used geometry to master perspective. Math became essential for art and science, setting the stage for the scientific revolution. Copernicus used math to show the sun, not Earth, was the center of the universe. Kepler discovered planets move in ellipses, not circles, and described their motion with mathematical laws. Galileo's telescope revealed new worlds, and he called the universe a book written in math. Newton united these ideas, inventing calculus to describe gravity and motion. His law of universal gravitation explained the cosmos with a single equation. Calculus became the engine of scientific progress. The scientific revolution proved math could unlock the secrets of the universe. Calculus, invented by Newton and Leibniz, let us study change, motion and growth, and curves. It powered the age of reason and the Industrial Revolution, solving problems in physics and engineering. Euler expanded calculus and created much of the notation we use today. In the 1800s, mathematicians explored non-Euclidean geometry and abstract algebra, questioning old assumptions. Galois founded group theory, studying symmetry and structure instead of just numbers. These abstract ideas seemed like games, but they built the foundation for future science. Math became more general, logical, and creative. The 19th century's wild ideas would soon change everything. Mathematics was now a playground for the imagination. The 20th century brought both crisis and revolution to mathematics. Gödel's incompleteness theorems showed some truths can't be proven, shaking the idea of absolute certainty. Einstein used non-Euclidean geometry to describe gravity as curved spacetime. Quantum mechanics needed new math based on probability. Alan Turing imagined the universal machine, the blueprint for all computers. Computers born from math now help us solve problems too complex for humans. Math became the engine of the digital age, powering weather models, simulations, and fractals. Chaos theory revealed how tiny changes can have huge effects. Mathematics became both the language of science and the heart of technology. Today, mathematics is the hidden engine of our world. Algorithms guide your GPS, encryption protects your data, and math compresses every song and movie you stream. Climate science, medicine, finance, and AI all rely on advanced mathematics. The biggest challenges, like climate change and pandemics, demand new math. Unsolved problems like the Riemann hypothesis still inspire. Math connects us to our ancestors and empowers the future. It's not just numbers, it's a way of thinking, solving, and creating. Math teaches logic, pattern finding, and creative problem solving. The adventure of mathematics is still unfolding. It's humanity's greatest story, and you're part of it.